Transformation is an operation that maps an original figure onto a new figure. It's called the image. So your original figure is called the pre-image. And then once it is placed onto another figure, it's called the image. Pre-image and image. That's a transformation. Taking one pre-image, putting it on a new graph, making it an image. Okay, second word is dilation. Dilation either, this is what we're going to be doing a lot of, enlarges or reduces the original figure. Enlarging obviously means getting bigger, right? I don't have to go over this. Enlarges is bigger, reduces is smaller. Since a dilation produces a similar figure, it is a type of similarity transformation. So anytime you're enlarging or reducing a similar image, it is called a similarity transformation. Dilations are performed with respect to a fixed point, which is called the center of dilation. Wherever it is in respect to a point. So in this example right here, your center of dilation is actually just the vertex, 0, 0. Most of the time, it is going to be just the vertex. So you can put example, vertex. What is the vertex? 0, 0. Vertex is 0, 0. Okay, dilations also can have a scale factor. It tells us what ratio the image is corresponding to. It tells us what the ratio is between the two images. Okay, in this lesson, we're going to refer to the scale factor as K. So whenever you see K, that's just a letter that represents the scale factor. Just like M stands for what? Most of the time. Slope. What's B stand for? Okay, y-intercept. In this case, we're going to let the letter K signify scale factor. We can find the scale factor to determine whether it got bigger or whether it got smaller. So here is enlargement. This box right here is enlargement. When you're finding the scale factor between two figures, if the scale factor is greater than 1, if it is greater than 1, then it was an enlargement. If it was greater than 1, then it's an enlargement. Give me an example. Scale factor of 6. Keep going. 5 over 4. 5 over 4. Is that larger than 1? Yeah? Okay, so if you have a scale factor of larger than 1, of greater than 1, then it's an enlargement. If you have a reduction, your scale factor, or what in this case? What letter? K is between 0 and 1. If your scale factor is between 0 and 1, that means that it was a reduction. It got smaller. What's an example of a scale factor between 1 and 1/2, 1/3, 2/3, 1/8, 1/4. As long as it's not greater than 1. Okay, so these are 2 examples right here. It's very important that you read the instructions to know which figure you're starting with. So it says, determine whether the dilation from A to B. So what was my pre-image? A. A is what I started from. That was my pre-image. So A is the outside, and B is the inside. So not even looking at the scale factor, if A, which is the outside, is my pre-image, and B is my image, did B get smaller or bigger? Smaller. So it was a reduction. B is smaller than A, so it was a reduction. Okay, to find the scale factor, it's not always going to be fun, okay? Because what if I wanted to use these sides right here? What if I wanted to use these sides from here to here? Can I count the number of boxes? Nope. But how can I find the distance between 2 points? The distance formula. Not always going to be fun. If it's a square, it's great, right? Rectangle. That's great. That is a big if. Okay? But it's not always going to be fun finding the scale factor because you're going to have to use this formula, so let's write it down a lot. Distance, story about a girl with long hair. How many eyes? 2 eyes. And a nose. What else? Pupils. What about her eyelashes? She got that squared mascara. Libby just let it go. X comes before. What? Dalton, you have no idea.
I know.
That's a good thing. That's a good thing that he has no idea. Alright, so let's find the scale factor of A. They've already done it for us, thankfully, because this is an example. The distance between the vertices, negative 3, 2, and 3, 2. So which ones are they talking about? Negative 3, 2. I'm looking at the right one. Yeah. So they're talking from negative 3, 2 to 3, 2, from here to here. How many boxes is in between those two on A, the top? What's the distance of the top of A? 1, 2, 3, 4, 5, 6. Okay? We can also use the top of B. Now, we're going to have to be very careful. In this case, I know it's 3. Why? Because it tells me. Because it tells me. But can I assume that these two are half? No. So we're not going to do the distance formula right here. But you can't assume that it's half. So in this case, yes, it goes from 3 to 6, which makes the scale factor 1/2. Is that between 1 and 0? So was it an enlargement or reduction? Reduction. Good. This case, what did we start with? What was our pre-image? A. So from A to big, did it reduce or enlarge? Enlarge. So my scale factor has to be greater than 1. Now, thankfully, I don't have to find the distance because there's a side. Look at B. What's the side of B? 4. What's the side of A? 3. So my scale factor is 4/3. Okay, here's a question though, and maybe y'all can help me figure this out. How do you know which one to put on top or bottom? Yes, ma'am?
Can you send Libby Greenwald to the attendance window for a minute, please?
Yes, ma'am.
Thanks.
How do we know which one to put on top? Because look, over here, it was B/A. Down here, it's B/A again. But B is bigger here, B is smaller here. The only thing I can figure out to tell you, this is an enlargement, right? So it has to be bigger than 1. 4/3 is over 1. 3/4 is not. You see what I'm saying? Did you have a different way? Okay, so why do we put B/A right here? Yes.
I think you just put the.
You see what I'm saying though? But we did put B/A, and it was A to B. But here B is in the middle. Here B is on the outside.
Oh wait, never mind.
I just thought there would have been a pattern. So, I'm going to dig into that some more. But, for today's purposes, if it is a reduction, it has to be smaller than 1. So, this couldn't have been a scale factor of 2. No, because you would get 2 over here. 6 over 3 is 2. Yeah?
Will you always know if it's a reduction?
Yes, if they tell you which one's first. Because from here, it was from A to B. So it got smaller. You see how B's in the middle? A was our pre-image. A was the bigger one. It got smaller to B. So it reduced. It'll always tell you which one was your pre-image. Yeah.
Because like right here it says A to B.
Mm-hmm.
So that means that like
A
would
was the
start-
pre-image. Yep.
Yeah. So then would you always that would typically.
But we put B over A here.
Well, here you still put B over A.
Now see what I'm saying?
This is confusing.
So, for today's purposes, and until I can get further clarification on this, if it is a reduction, it has to be less than 1. So your scale factor has to be 3 over 6, not 6 over 3. If it's an enlargement, it's bigger than 1. So the scale factor cannot be 3 over 4. Okay, this is okay. Let's go on. I want you to try these 2 practice problems. Determine whether it was, yeah, y'all see that example? Okay, these 2 right here. These 2 right here. Tell me if it was a reduction or an enlargement, and tell me the scale factor from A to B. From A to B. Just these 2. No, guys, don't look at this. What we just did. What we just did on the front, I want you to practice those right here.
What do you mean from A to B?
A is your pre-image. A is your pre-image.
Oops.
I want you to try those 2. I just want to know if it's an enlargement or a reduction. Then find the scale factor. You don't have to use distance for either of these. Okay, A was your pre-image. So for number 1, A is the pre-image. From A to B, it was an enlargement. Got bigger. The scale factor. What's the biggest one? What's the biggest piece? Is B, right? So our distance is 1, 2, 3, 4, 5. 5 over 1, 2, 3, 4. I wonder if it has to do with putting the bigger one on top and the smaller one on bottom.
But you don't put the bigger one.
Hmm?
You
You
put
put the bigger one on top of B, right?
Mm-hmm.
So 1 B.
So bigger, because it's an enlargement, so big over small.
the
Okay,
reduction.
what about over here? From A to B, this was a reduction.
Yeah.
Yeah. But here, since it's a reduction, the smaller over the bigger.
Oh, you put whichever one you started with on the bottom.
Yeah, you put like the.
Whichever one you start with on the bottom?
Put the end. You put like the
enlargement.
end image on top.
Yeah. So that just clicked in my head. I don't know if it does in yours. Enlargement, biggest over smallest. Reduction, it gets smaller. So smaller over largest. 1, 2, 3, 4, 5, 6. So the scale factor is 1 over 3.
And it's always going to tell us
A to B. Yes. All right. We're going to skip this for today. Right here. We'll come back tomorrow. What I want you to do tonight, 3 through 8. 7 and 8 are literally just writing, did the pupil get bigger or smaller? That's it.
What about 8?
8 is, did this get bigger or smaller? Okay, can y'all handle 7 and 8?
I can try.
Okay, 3, 4, 5, and 6, and 7 and 8.